Yeah, welcome back. As promised, we are back. Okay. Now we can erase this old board, okay? So it's not metallic, so I cannot use magnet to use that nice eraser placer. Okay. It's alright. I only have two boards, so. Okay, two-dimensional space, man. Oh boy. Simple case, okay? We'll do push and pull. We'll combine push and pull later. But for now, just two pushes. F1, F2. Okay? They don't have to be equal length, alright? But principle is the same. Yeah, in a classical vector summation, right? This is equivalent to, okay? Square root of 2 F1, okay? Vector summation, right? You have two vectors. You draw this parallelogram, right? This diagonal. That's the vector summation. Why? Because you go this way and you go this way. It's as if you went diagonally. Okay, that's the vector summation. Okay, so you use Pythagorean theorem, and then this so f1 plus f2, what's the absolute value of that? Square root of f1 squared plus f2 squared. Okay, you remember the index notation, index convention in humanology? Yeah, you can move it around. Clockwise, counterclockwise, you can move it around as necessary. Okay, same thing. Because we are using this power symbol, okay, we have to push it down, push down the index. Okay, handy dandy convention. Okay, rotational index system. Okay, yeah, we're dancing it around. Okay, as necessary. Okay, can you see this? If I can see this, so can you? Yeah, you can. Because I'm watching it on the screen, laptop screen. So, oh boy. But is this correct? That's my question. Can we come up with a generic formula? Well, okay. What's the general formula? For some arbitrary angle theta. Let's just derive that, okay? So, I almost said, let's drive that shit. You have theta, okay? Alright, so we draw the parallelogram. This is what we want to find. Alright? Okay. My goodness. A, B. Let's say these two vectors are different length and it has this theta angle, okay? Um, so you have A here, B here. My goodness. Angle theta here. This is A cosine theta from here to here, okay? This guy height is A sine theta, all right? This diagonal of this parallelogram is, let's say, is X, okay? So can you read all this? I'm sorry, it's so small. Yeah, you can read this, okay? Kind of, right? A sine theta, right? So when I'm watching this on the screen, it's like left side, right. It's like mirror image, so hard to read. But in the recorded video, yeah, it comes out right. Right side, right. Okay. All right, so let's do a Pythagorean theorem, okay? All right. X squared. I'm kind of far away, so I'm going to use black. X squared is equal to A squared sine squared theta plus B squared plus B plus A cosine theta squared, okay? So B squared plus A squared cosine squared theta plus 2AB cosine theta, okay? Which is sine squared theta cosine squared theta is same thing. So A squared plus 2AB cosine theta plus B squared, okay? So that's the generic formula. Is this right? I thought it was sine. Was it? I don't know. Okay, let's say what if theta is 0? Alright? Then cosine theta is 1. So yeah, A squared plus 2AB plus B squared is A plus B squared. So yeah, when theta is 0, collapsed, then you just add them up. What if theta is 180 degrees? Cosine theta is minus 1. Okay, so A minus B squared, and so X is square root of that, and so it's A minus B. But it's opposite direction. So yeah, this is correct formula, okay? So okay. Where's A is equal to B? Okay, then it's A squared, A squared, A squared, it goes out. So A times X, so X is equal to, oh, it's running out. X is equal to square root of A squared plus B squared plus 2AB cosine theta, okay? If A and B are equal, you have A get out of the square root, right? Can you see this? If A and B are equal, then A squared, they get out of that, and so when A and B are equal, okay? A get out, uh, a squared plus a squared, okay, 2 plus 2 cosine theta, okay? And 2 gets out, square root 2a, square root 1 plus cosine theta, okay, when a and b are equal, okay? Now, if a and b are equal and then they are like right angle, then cosine theta becomes 0. So, yeah, square root of 1 is 1, and so it's a square root of 2. Square root of 2 times f, okay? We got it, okay? Here's correct formula, alright? So, now, in terms of pressure, is this right? That's my question. We know in terms of acceleration of a body, yeah, it's easy, right? Yeah, it is correct. It's just vector summation of two forces, right? But we realize that in terms of this stress, it kind of behaves opposite, okay? When two people are pressing me, pushing me in the opposite direction, yeah, acceleration is 0, right? Because it's two forces in the opposite direction, so acceleration is 0. I'm not going anywhere. Two people pushing me opposite direction, but the stress I'm experiencing doubles. Okay, so acceleration is 0. My stress doubles. Okay, now if somebody pushes me and somebody pulls me, acceleration doubles, but stress I'm experiencing is 0. It cancels out. So stress and acceleration, that they work opposite way. They behave opposite way. Okay, so we're gonna erase all this. Okay, so we'll find some humanological application later, but first we need to understand physical phenomena before we do metaphysical application. Okay, we need to understand physical phenomena first, then we can apply to understand metaphysical phenomena. All right, so or maybe we can just apply metaphysical phenomena right now. Okay, so this big planet, okay? Oh, this brown is running out too. I'm gonna use orange. I love orange. It's my favorite color. Big mass, M1. And I'm just small guy, okay? Underdog, okay? Equal distance, okay? Another big mass, M2, but they're equal in mass, okay? So I'm being pulled here, being pulled over there. So what do I end up going? Yeah. Do you know what happens? What do you think happens? I know initially I will go there, right? What happens if I go all the way here? I was to think about this, okay? Initially I was here, then this big mass, 2 equal weight. What happens? Yeah, I know I go there. I will not go there. There, we take it in the middle, right? What happens when I go over here? Take a break, and I want you to give me that answer. If you took some physics class, probably this is a piece of cake. Okay? But if not, it's a quiz for you. Come up with an answer for me, okay? After a break, okay? Very interesting physics problem, alright? It's very well-known phenomena, by the way, okay? So if you have taken physics class, this is a piece of cake. But if not, it's a quiz for you, okay? Alright, we'll be back. Okay, we are dancing with physics. We are having fun with physics, okay? So, I'm gonna grab another drink. Hmm. So, what's your answer? What's the behavior? What's your prediction of the behavior of this small guy? Huh? Do you need more time? Yeah, tell me. You had enough time to think about it. Now it's your time to present it to me. What's the answer? What's the behavior of this small guy between these two giants? Let's say it's a frictionless surface, two-dimensional surface, and this guy, these two big guys, is bolted down. Okay? It's fixed with a nail, or screw is fixed. But this small guy is free to move around. So how does this small guy behave between these two giants being pulled by two big guys? It's very humanological, okay? It goes back and forth, back and forth, back and forth. Like a pendulum. Goes like this, can slow down, then go back, accelerates, then slow down, back and forth. It's like two guys and there's this girl. Okay, they are all adults. Okay, two guys. Okay, both muscular, like hunky muscular guy, right? This girl, but they're all, let's say they're all 25 years old. Okay, they got all good jobs. Okay, so they're free to date. Okay, nothing wrong. Triangular relationship. Okay. By the way, I was reading this all these biographies of Dirichlet and Dirac and Cauchy and Galois, Abel. Yeah, Galois, Abel, they were not professors, okay, because they didn't get a PhD, but they just college graduates. Galois and Abel, group theory, okay. Yeah, the guys who solved that quintic equation unsolvability beyond fourth degree order equation, polynomial equation. Yeah, you cannot express with radicals. Okay, it's not expressible. The solutions of fifth degree and on, sixth degree, seventh degree. There is no general formula for that. Okay, expressible with radicals. Okay. Yeah, Galois and Abel, who both of whom died young after they got engaged. Abel died when he was 25. Galois died when he was 20. Galois was French. Abel was Norwegian. Great loss of these brilliant young mathematicians. Galois died in a fight. Kind of foolish, okay? Young and dumb, I guess. He was also a political activist. Okay. So, one story says Galois was loving this girl and was entangled in this triangular relationship. He had a duel and he died. He got shot to death. Okay, so horrible. Okay, Abel died from tuberculosis after he got engaged. Okay, yeah, but they created this what's known as group theory. Okay, in mathematics, we talked about a lot of group theory, but I don't know too much about it. I don't know too much about it. I just know basics. Okay, I'd like to learn more, of course, later if I have time. Okay, I'm too busy creating my own theory, our own theory. Okay, so yeah. And Abel famously said something like, "I don't learn under a big master. I learn beside a great master because I don't want to be dictated by this master. I kind of learn over the shoulder. Okay, kind of not from the front door, but from the back door or side door. Okay, yeah, this great philosophy that he had, philosophy of learning. Yeah, you don't want to be possessed by your master. Yeah, I will take master's teaching with a grain of salt. I want to create my own theory. So yeah, that's kind of what we are doing here. Okay, I don't belong to any academic institution. I want to be independent thinker. But do I learn things from academia? Yeah, I buy textbooks, go to Wikipedia, but I don't want to belong to an institution. I want to be an independent thinker. Okay, I don't want to be dictated of what I should be researching. I want to research whatever I want to. Okay, so yeah, kind of sideway kind of learning. Okay. Okay. We're just taking a break, taking a breath, right? So, okay. So yeah, swinging pendulum. Okay, between two big guys, or this Democratic Party, Republican Party, and small guys like us, just kind of pendulum swing, going back and forth, back and forth. Or two guys, attractive guys, rich guys, This girl, oh, what should I do? Oscillation. Okay, vacillation, vacillate. Yeah, I cannot decide. I cannot make a decision. There's this great episode in Twilight Zone series. This guy went back in time and became the president of the United States. And then there's this UFO invasion, and scientists say, we should welcome those UFOs because it's great scientific research of those aliens. And then military guys say, no, we should destroy them because let's err on the side of caution because we don't know what their motivation is to visit us on Earth. They could be our enemies, so let's shoot a missile and destroy them. And this president says, I cannot make a decision. Yeah, two opposing councils, okay? You cannot make a decision. Let's say it's in a trial court, okay? Yeah, there's this judge, defense counsel, plaintiff counsel, judge. I cannot make a decision. I want to take the middle way. So let's just, Solomon, right? Yeah. So Solomon didn't actually kill that baby, split the baby. He didn't do that. He did so because he knew the real mother of this baby, Solomon, the king of Israel. Third king, there was Saul, David, then Solomon, right? Third king of Israel. Yeah, I know the real mother will yield to this fake mother because she does not want this baby to be killed. So Solomon never actually wanted to kill the baby, split in two. No. Okay, so all right, so in this situation, in traditional vector, you go this way, right? It's a vector summation of two different forces, okay? FA, FB, okay? FC. C is equal to A plus B, okay? So FA, we call this FA plus B, okay? Okay? Which is equal to FA plus FB, okay? We call it F of A plus B. Yeah, it is vector summation, okay? So what kind of pressure does this M feel? Yeah, it's the pressure of FA plus B. Okay? In this situation. Okay, because that's the direction it's going. Okay, so. So that was the initial positioning of the small guy, M, small m, okay? Now we're gonna erase part of this picture. Okay, because it's interesting, isn't it? I'm having fun. I don't know about you, but I'm having fun. I hope you are you're having fun as much as I am having. What is initial positioning of the small guy M is right here. We draw in orange, okay? Can you see this orange color? I'm sorry, I hope you can. Yeah, you can see it clearly. Loud and clear. Lima and Charlie. What is Lima and Charlie? Loud and clear. It's military. Because you have Alpha, Beta, Charlie, A, B, C, D, E, F, G. Because in this radio communication, if you say A, it kind of sounds like D or K, so they give it some nickname, cosine, whatever. Alpha, Beta, Charlie, Delta, E, I forgot what it is. But yeah, Charlie, Lima is the nickname for L, okay? Nickname for Z, Zulu. I know that. What is Zulu? I'm not sure. It's some kind of African dancing or African tribe. Zulu? I'm not sure. Okay. Anyway, initial positioning is this M. Okay. Now you have two vectors pulling in opposite direction. Okay. So F1 and F2. So here the let's say FA and FA and FB, okay? FA plus B, okay? We have the vector hat, okay? FF plus B equals zero vector, okay? Because it cancels out, so it's not moving. Just stay there. But stress is not zero though. That's the difficulty we are having. I mean, in this physics and astronomy, there's this notorious problem, three-body problem. Okay. We are not doing planetary motion because we are assuming M1 and M2, they're fixed, they're screwed in, they're tight, nailed in. So M1, M2, they are not moving. It's not planetary motion. In planet, oh, things move around. Nothing is tying down anything, right? Earth and the moon and the sun, it's not screwed in somewhere. No, they're free to move around, you know. So planetary motion is a very, very complex system. But nothing is tied down. We are here, we assume M1 and M2 is tied down. Okay? They're not moving, they're not going anywhere. We are simplifying a lot of things here. Okay? I think it's time to take a break. Okay, so let's take a break. Okay. The question I'm going to leave you in this break. How should we formulate stress in this two-dimensional space? Because here we have to double the force. We cannot make it a zero force in terms of stress. In terms of acceleration, yeah, it zeroes out, right? But in terms of stress, it has to add up. So we cannot just do vector summation. That's the point I'm making here. Okay, it's double the stress here. So what will be our stress formula? Generalized in two-dimensional space. Okay? Okay, think about it. And better yet, yeah, come up with a solution. Because I don't know. Not yet. That's why I'm taking a break, okay? Yeah, my vocal rest. My vocal cord needs some break too, so. Okay, we'll take a break. Take 5. Oh boy, I have no idea. I mean, can we say, should we use sine theta instead of cosine theta, or should we use minus cosine theta, or here f of a plus b, okay, I mean the absolute value a plus b, okay, is equal to square root of f a squared plus f b squared plus f a f b cosine theta, right? And theta is 180 degrees, so cosine theta is minus 1. But we don't want it to be minus 1. I mean, I'm sorry, twice of this guy. Can you read this? I'm sorry, I'm writing very small. Okay, sorry about that. But I have very limited space. Oh boy. Oh. Oh. I'll show you. Okay. Here. Okay. Yeah, just traditional Baxter summation. All right. It's in physics books, mathematics books. Okay. So, when theta is 180 degrees, like pi, this guy become minus 1. So that's why it becomes fa minus fb. It becomes subtraction. But that works when we try to calculate the acceleration. Okay. But when we are not trying to calculate acceleration, it's already known. We know it works. We are trying to calculate stress that this middle guy is feeling. Let's say your mother and your father is fighting, okay? Hey baby, come to me. And your father is saying, hey baby, come here. Don't go to your mother, she's evil. No, he's evil, come to me. They're divorcing. Okay. Now, the child, poor child of these divorcing parents, oh my goodness, not again. Why all you guys do is fighting? There's a line in TV series 24. Okay. Jack Bauer's brother, Gray Bauer, and his wife. What's her name? Blue-eyed, pale-skinned, black-haired brunette. Yeah, she's very good-looking actress. Okay, I forgot the name of the character. Okay. So yeah, and she happened to be the former girlfriend of Jack Bauer. Okay, in the TV show 24. Right? Graham Bauer and this Mrs. Bauer, they fight all the time. Okay, so their son, the nephew of Jack Bauer, oh, he's saying, oh, you guys, all you do is fighting. Stop it. So yeah, if you are a child of divorcing parents, you are being pulled. Should I go with my mom or my dad? Oh, because divorce court, family, in a divorce case, it's always about the best interest of the child. And the court, the divorce court, family law, judges, they listen to their children. I mean, the child of these divorcing parents. What do you want? Well, I want to go with my father, but I want to go with my mother too. I don't know what to do. I'm being pulled apart. They are like having this tug of war, pulling my arms in the opposite direction. It hurts. It's painful. It's like torture. Stop torturing me! Jesus is very against divorce. Okay, so they should just work it out. Yeah, there are some cases when people need to divorce because if husband is physically abusive, oh come on. Yeah, divorce is good when husband is physically abusive. Come on. Yeah, you got a divorce. The judge is easy case. Yeah, you go with your mom because your father is abusive man physically. Okay, so it's not good for the child. So yeah, easy case, right? But if it is not physical abuse but verbal abuse, then yeah, okay, whatever. So yeah, child is being tortured. Okay, we cannot just cancel out this force. It's not like child is feeling nothing because two parents are have pulling the child in the opposite direction. It cancels out in the vector summation. He's in the middle, child in the middle. He's not going anywhere. But in terms of stress, the child is feeling. Yeah, it's double the stress. He's pulling up, being pulled apart. Okay, so we are doing physics and metaphysics at the same time. Okay, so because we don't want to wait too long. Okay, so boy, let me put on my nightcap. Okay, so and scarf. It's kind of getting late. What time is it? My phone is charging, so I have no idea. Probably like 10 o'clock at night in Alaska. Yeah, it's getting chilly. Anyway, so yeah, cosine theta, cosine 180 degrees is minus. It cancels out, but no, we cannot put minus sign here. We should put positive sign here. But sine theta, if we substitute sine instead of cosine, sine 180 degrees is 0. Okay, so no, we cannot use that. We want this something theta, that function, we want that to be 1. Not minus 1, not minus 1, not 0, but 1, plus 1. Okay? What if we use minus cosine theta then? Well, then we have problem because when theta is 90 degree, maybe it works because minus cosine theta plus cosine theta 90 degree. Oh well, cosine 90 degree angle is 0. Maybe it works. Maybe we should use minus cosine theta instead. Okay. What is theta? What if theta is 45 degree then? I don't know, man. Oh boy, such a mess. It's difficult problem, okay? Stress. That's why they didn't get it right because it's something very challenging. Can I get it? Can we get it right? I don't know. Okay. Oh, I'm getting hungry. It's Saturday night. What the? I'm not gonna use F word. What the hell am I doing? I use H word instead. Does it go down better? Again, it's line from 24. Oh. too hot. When I get stressed, I get hot. Okay. Woo! Well, I'm gonna turn off the heater. Is it time to take a break yet? I don't have a clue. Really don't. If theta is 90 degree, yeah, cosine theta is 0. So using minus cosine theta instead of cosine theta, it will work. What we are doing here is to calculate the stress force. Okay. Oh boy. What if this theta is 0? If you use minus cosine theta instead of cosine theta, cosine 0 is 1, okay? And now we are subtracting, and that's wrong. Because if you use minus cosine theta, cosine 0 is 1, so it will be subtraction, and that's wrong because your theta is 0, so when theta is 0, you should add them up, not subtraction. Okay. When theta is 0 or when theta is 180 degrees, they should both be adding, not subtracting. Okay. I think we are getting close. Okay. We need to come up with some kind of trigonometric function. Okay. When theta is 0, when theta is 0 degree, when theta is 45 degree, when theta is 90 degree, when theta is 135 degree, when theta is 180 degree. Okay, this function trigonometric, some kind of combination, some trigonometric function, it should be 1 here, 1 here. If it's 90 degree, it should be square root of 2. No. Zero. Okay. 1 over square root of 2. Okay. And minus 1 of square root of 2. Okay. Woo. Okay. Minus 1 over square root of 2. Okay. Something like this. It's just something that looks like cosine theta, but not exactly, because we want one. Maybe it should be cosine theta of absolute value of cosine theta, maybe. Okay, maybe it should be absolute value of cosine theta. Yeah, maybe it doesn't have to be minus square root of 1 over square root of 2, but you could, yeah, because uh yeah, I think we got it. Maybe f is equal to absolute value of cosine theta, okay? Tentatively, right? I think so. Okay. Because we are talking about stress, okay? So, when theta is 180 degrees, yeah, people are pulling you apart, okay? So cosine theta is -1, but it doesn't matter. It's going outward. It's a radial system concept, egocentric coordinate system concept, okay? If it's going out, it doesn't matter if left or right, okay? Money is going out, Doesn't matter what kind of expenditure that is. Money is going out, period, okay? And when theta is 0, yeah, now it's making sense. It has to be absolute value of cosine theta. We got it, okay? It's the stress force. It's not accelerational force. We don't care about acceleration. We are trying to calculate stressional force, stressor force, stressional force, whatever. Stress force, okay? That's what we're trying to calculate. Yeah, we just put the cosine theta absolute value. Such a simple thing, but it took us a long while. But I think it works, okay? Yeah, cosine theta goes like this, okay? Pew, 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 pew. Okay? It's 180 degree. So, absolute value of that is like pew, pew. It's like fence, okay? So that's that. Flip it, alright? That's absolute value of cosine theta, okay? I think it works, okay? Yeah. Yeah, okay, I think it works. We'll take a break and then we'll come up with this nice equation for stress in two-dimensional space. Okay? We'll take a break. Good, very good. Making progress. Such a simple thing. Put an absolute value around that, 2 bars. But I was scared, Take a break. Oh boy. Okay. Let's take a break from this, okay? So we talk about something. Let's talk about cigarettes and alcohols. Yeah, you know, back in the days and even nowadays in some states, like pharmacy, like Walgreens or whatever, they used to sell tobacco, okay? Because cigarette and alcohol is they are like drugs, okay? So any drug overdose is harmful. This is threshold, okay? Dosage. Any drugs work just like tobacco and alcohol, okay? Tobacco and alcohol is just drugs, okay? You cannot go over the threshold, then it will start to harm you. But if you smoke and drink in moderation, yeah, it's good. Okay, you need it, right? How about food and water? If you drink too much water, you will die. Okay, if you eat too much, you will die too. Okay. Yeah, don't go over that threshold, then it will start to harm you. But if you stay in the dosage within this threshold, then yeah, it will help you. Okay? Okay, anyways. Yeah, so I think we got it, okay? Now, we go back to one dimension, okay? Because we need to think about push and pull, alright? Because we're trying to generalize, okay? Push and pull, can we express it with in terms of just theta, angle? No. Why? Because you have a body, M, right? If there's two different forces, F1 and F2, they're both pushing. One person is pushing your back, another person is pushing your back too. Then you will have to add up. But what if F2 is not pushing but is pulling? We call it F2 prime, okay? Then it will cancel out. Why? Because it's pulling, it's not pushing, okay? We'll have index notation convention. Pushing inward, pulling outward. O and I. In, out. Pushing inward, pulling outward. Okay? That's our notational convention from now on. Okay? So that's very important distinction. Is because it has opposite effect. It's like +1 and -1. Okay? Okay, so we will need to use this Boolean hybrid algebra equation. Okay, we are mixing real algebra with real numbers like +10, -10, and then we are also using Boolean algebra, 0 and 1, true or false. We have to use that. Okay, so and we have theta because we are going to deal with in, out, and also theta. Theta comes in only in 2-dimensional and beyond. Okay, we're not going to talk about 3-dimension, dude. 2-dimension, that's enough. Okay, at least for now. Okay, so we got it down. Okay, so let's move on. All right. It's getting a little bit chilly. I know it's annoying, I'm sorry, but I'm expending a lot of energy, okay? So that's why. You gotta excuse me, okay? I'm such a temperature pussy. Temperature pussy. pusillanimous in terms of temperature. Oh, it's too cold. I'm sensitive in terms of temperature. Because I'm expending a lot of energy here, okay? Whatever. Ah, boy. Okay. So there's a body, okay? And we'll do pushing, okay? F1, F2, okay? The stress force, okay? This guy is experiencing. Poor guy, right? Well, we step back, okay? Let's say F1 and F2, okay? The stress force is the force that stress force is not acceleration of force, okay? It's the force this guy is experiencing in terms of stress, internal stress. Okay, we are not talking about acceleration. We are talking about stress. Okay. I think it's very unexplored area in physics. Okay, so yeah, I looked at it, this Cauchy stress tensor, and I was not satisfied with what he was doing. Okay, it's not just him. Many people. Just like in economics, okay? Yeah, Alfred, Marshall, I wasn't quite satisfied. So we came up with brand new equation, you know. We're doing the same thing here, okay? We are fighting with we are challenging the giants. We are challenging giants, not just one, many. We are coming up with brand new physics here, okay? Okay, stress force, all right? So, we just call it stress, okay? Stress is pain, okay? Pain or pleasure. Well, it's always pain. Okay. Somebody pushing you, oh, you feel the pain. Someone's pulling you is pain. But push and pull, well, it cancels out, right? We are doing one dimension, okay? We went back to one dimension, okay? So, because we want to find out how theta works. We have theta and we have in versus out. Okay, they're two different things. We want to find out some interrelationship between these two. Okay. So stress is stress in, okay, was equal to sigma. We're going to use J as an index, okay? F in J something like this, right? Let me pipette that equation, okay? push. Yeah. Okay, this acceleration of force. Okay. My goodness. You have in and out and then with inertial. Oh, same eye. My goodness. We have to. I'm being annoyed. We have to reserve I for inertial. Inertia. Oh my goodness. Inertia, acceleration, in and out. Ah. We use T. T for towards. Okay. Is it toward or outward? Okay. We have to reserve I for inertia. Okay. What a mess. We are running out of alphabet. Okay. Is it toward or is it outward? Toward or outward? Okay. Accelerational force. Okay. Well. My finger is hurting, okay? My goodness. Yeah, it kind of looks like that. Good. I'm getting sleepy now, okay? So sorry. Sorry about that. I'm getting sleepy. Oh. Well, it's because when theta is 0, you're heading with F1 and F2, okay? F1, F2, okay? It's a vector summation, alright? So when theta is 0, cosine 0 is 1, okay? Alright. Alright, and what if F2 is like this? That's F2, okay? No problem. Why? Because cosine theta of 180 degrees between these two, okay? F1 and F2. Yeah, we put the absolute value of that. So yeah, it will be not -1 but +1, okay? Yes. So in this one-dimensional space, yeah, this one works, okay? And this inward, like toward, like pushing, okay? So we're gonna put this guy T, okay? But in two-dimensional space, it won't be like this, okay? Let's put this 2 out of here, okay? Forget about all the absolute value, okay? It's just unnecessary. Okay? Can you read this? Yeah, you can kind of read this. Okay, so here. Here. Okay. FA1, FA2 squared, FA1 times FA2, okay, times cosine theta absolute value. Okay, so that's the general formula. All right. Oh boy. But what if there are more than 2 forces? Then we have to do it in successive fashion. You know, when Galois, I think his name, first name is Francois or something, Galois, no, Évariste Galois, okay? When he wrote these papers, the senior people like Jacobi or I think I don't think it was Jacobi. It was Poisson and Cauchy. Yeah, they reviewed Galois' paper. He was just college graduate. I'm not sure if he even graduated from college. He was not a professor with PhD. Okay, but he submitted his mathematical academic paper anyway to academy authority. You know. When they read his paper, Galois' paper, oh my goodness, I don't understand what the fuck he's saying, you know, so they rejected that. Not many people. Yeah, some small journal published his paper, but probably nobody understand what I'm saying. Oh well. But Galois, when he published paper, nobody understood what the fuck he was saying, what the hell he was saying. But later on, they tried to understand, and they did. Okay, that's Galois theory, like Galois group theory. Okay, so whatever. Maybe one day some people will understand what I'm saying here. Okay. Oh boy. If not, that's fine too. Well, I'm having fun. By the way, I forgot this number 2. Just vector summation, okay? Variation of that. Okay. Ah, boy. Let's reserve the right shoulder for power operation, okay? Ah. A, J, all right? A1. We don't want to confuse anybody. We gotta be as lucid as possible because it's complex as it is, man. Okay. My goodness, look at this orgy of indices. Oh boy. Here again. Sorry for the goof up. All right. Is it better now? Huh? Well, I'm doing my best, okay? Okay. I'm doing everything I can with this limited budget and all that. Limited budget, limited energy. I'm getting hot, so I'm gonna turn off the heater. Why don't you chew on this for a while, okay? Ooh. Turn off the heater. Man, we're doing a lot. Turning off and on the heaters. Okay. What if there are three vectors, three forces? Is same. We do it in a success fashion. We use this associative law. Okay. There are three vectors. We take care of the two first, and then we merge it. We sum it. Okay. Then this a plus b is now one vector, f of a plus b. Now we do that the same procedure, same algorithm, same formula between f of a plus b and f of c. Okay, so that's the algorithm. We do 2, then 2, and 2, 2 by 2. Okay, so it's a simple concept, but to express that algorithmic concept in a formula, one single formula, it can get very messy. Okay, just to let FYI. Ugh. And it have this kind of unreadability. It happens between mathematicians too. Okay, one mathematician come up with this formula, and some other mathematician look at it and, my goodness, what the hell are you talking about? I don't know what you're talking about, man. What's all this? But fortunately, we now have not only pencil and paper like back in the days. We have internet, we have camera, we have laptop. So that's why this is a preferred method. I'm not publishing any paper unless they hire me as a professor. Before then, I'm not writing any paper. Okay, I just do only this. We have whiteboard, we have pen, so I can give you a lecture instead of writing paper. Okay, it's more interactive. We are adding time dimension. Paper is just space, right? Yeah, but here we can erase, write again, and we have some technological advantage. Why don't we use it? This is my one and only publication, unless somebody hire me as a professor. Okay, this is all I'm gonna do. I'm not gonna write it down and try to publish it in an academic journal. I'm not doing that. Okay, been there, done that. Okay, I don't want it. All right, you are welcome to publish this in an academic journal. Okay, yeah. Okay. We are only dealing with this push towards stress force, okay? So we can omit T for now, but when we start to introduce this pull too, yeah, then we'll do T and O, towards, outwards, inward, outward, okay? So, you know what? Maybe we should just use I, because inertial force, well, yeah, we understand. It's just 2 times, it's same as the acceleration of force. So we're not going to use inward anymore because it's just same as acceleration of force, action and reaction. Or we can use reactional force, inertial force, reactionary force. We may use R because it's kind of awkward to use T, okay? So yeah, we'll just in and out, okay? For the inertial force, we use reactionary force, R instead. Okay, but it's not gonna come out very often. So okay, all right. We'll do two dimension now. Okay. Let's take a break. Okay, we'll be back. Oh, heavy, heavy, heavy. Whew. Whew. Ah. Okay, we're back. Oh boy. Our next step, we gotta come up with association, okay, divide and conquer kind of a succession kind of thing. It's something new, all right. You have to brace yourself because it's something new, okay. It's not gonna be easy. Maybe it is, okay. So we have F1 and F2. We are doing vector summation, okay. So you have one body. It's all push for now, okay. F1 pushing this way, F2 push this way, F3 push that way. Blah 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 blah. Okay. We are summing them all up, and we want to calculate stress force, the summation. Okay. All these different forces. There are n forces, n, general number. Okay, we're summing them up. Okay, so it's like this. F3. Okay. We first using the law of association. This is equal to, yeah, we calculate, add them up to force to first, and then we add them up. Okay. Well, let's say A, B, C, okay? A, B, C, okay? This is a resulting force is A plus B, F of A plus B. Now, we now add these two guys together. So then we have F of A plus B plus C, okay? That's what we are trying to achieve. Can you read this? Yeah, you can. Good. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Happy, happy how I am. Now that I know A, B, C. Alphabet. Okay. Yeah, it doesn't matter. We're just doing 2 by 2, 2 by 2, 2 by 2. Okay. And we will so that's the theta. Okay. It's theta 1 is the angle between A and B. What is theta 2? Theta 2 is angle between F of A plus B and F of C. That's theta 2. Theta 3, F of A plus B plus C and F of D. That's theta 3. My goodness. We gotta come up with one single equation to express all that shit. That's our challenge. Notational challenge, okay? Oh boy. It's a big deal. Yeah, it's about notation convention, but it's a big deal. I mean, look at this Einstein convention, right? In tensor calculus. It's a big deal, okay? It saved tensor analysts great big of trouble. It saved them a lot of trouble, okay? Einstein convention. It's something very simple, but it's very important. Notational convention, okay? Look like something small and formalistic, but it is important, all right? So, oh man. Looks like an insurmountable mountain, but we get it, okay? Because, it's good that I'm doing this at home so that I can drink vodka. I'm like, I need some drink. Oh, boy. I cannot do this without vodka. Okay, it's good that I'm not a professor because I cannot drink and lecture. I cannot drink in the classroom or in my office. No, it's good that I'm doing it at home. Because I cannot do this without drinking because it's too much. Okay. My goodness. A, B, C, D, E, F, G. We have to call it A1, A2, A3, A4. Okay, because we run out of alphabet. There are only 26 characters in the alphabet. Okay, so we have to call it A1, F of A1. Okay, I'm sorry. It's indexing of indexing. Okay, it's subscript of subscript. I'm sorry, but there's no other way. In tensor calculus, they do that. Okay, F of A I. F subscript and subscript of subscript. There's no other way. Okay. All right. Yay. Okay, so F of A1, F of A2. Okay? The angle between these two, we call it theta 1. Can you read this? Pen is running out again. Okay, oh my goodness. I gotta buy a new set of pens. It's like this, okay? You have F1, FA1, right? What if we just call it F1 instead of FA1? It's because, look, if we call this F1 and F2, then F of 1 plus 2, that's not equal to F of 3, okay? So that's why we cannot use just 1 and 2, because, okay, F of A1, okay? We call it F large A, okay? And you have F large B, and you have F large C, okay? Here, initially, that's the theta 1, okay? Now, we add these two, FA and FB, okay? Which will look like about this, kind of in the halfway in the middle, okay? That's F of A plus B, okay? We cannot call this, yeah, if we use F1, F2, F3, then F of 1 plus 2, that's not equal to F of 3. That's what I'm saying. Okay, we cannot just use 1, 2, 3. We have to use A1, A2, A3. Okay. That's what I'm trying to tell you, okay? Okay, so the angle between F of A plus B, angle between F of A plus B and F of 3, I'll redraw it for you. That's F of A plus B, okay? And this is F of C. And this brand new angle, we call it theta 2. Okay? FA, FB, and FC. We have to sum them up. Okay? And we'll do just 2 by 2. We first add up fa and fb, and we come up with f of a plus b. Okay, that's the result summed vector, summation vector. And then we'll do f of a plus b plus f of c. Okay. Easy concept. I know it's a lot. Even if you know mathematics and physics, it will still take some time for this to sink in. Because something new. Okay? Alright. I have no idea if anybody will be studying this or not, but I am, okay, and I'm having fun. Maybe one day some people will study this. I don't know. And to be honest with you, I hope somebody studied this because it's a good stuff. It's good stuff. It's something new and it's valuable. I think it has some value in it, okay. But if nobody studied this, that's fine too. Because I'm having fun, okay. It's Saturday night. Around midnight. I'm having fun. Okay, so that's good enough for me. Alright? Okay? Alright. I'm having fun, so that's to me good enough. If somebody else have fun, even better. If not, that's fine too. Okay, so oh boy. All right, so we have f of, pen is running out. We have f of a1 plus f of a2 plus f of a3 and blah blah blah, okay? The resultant vector of these two is this, okay? I mean the magnitude of these two. We are being flexible. We are cheating a little bit, okay? We are not doing this vector head, absolute value. Forget it, okay? Let's just regard it. We'll take it easy, okay? Well. You add them both, okay, and then the magnitude of that is in terms of stress vector, okay, stress force, all right? Ooh. F of A1. Yeah, we'll omit the absolute value, okay? You are doing squared, yeah, it's obvious it's absolute value of that. Okay, how about this? Without this vector head, it's absolute value. Notational convention, okay? Sure. All right? Does it go down better? ah. Without vector head, it's absolute value, okay? So My goodness. Let's say this guy is a vector, okay? It's a magnitude of this and some direction, okay? Alright. My goodness. I told you it's gonna be a challenge. It's gonna be messy, okay? But just follow, just chug along with me, okay? Just follow along, alright? Just tolerate me, okay? We are doing brand new thing. We'll organize this and we'll tidy this up later, okay? So you have f of a1 vector, f of a2 vector, and f of a3 vector, okay? Now we are adding these two guys, okay? Then this resultant vector is f of a1 plus a2, okay? That's this guy, all right? Oh my goodness. And we call this guy as f of a1 plus a2, right? This vector, huge vector, okay? F of a1 plus f of a2. F of a1 plus f of a2, okay? Plus f of a3, okay? The angle between these two vectors, we call it theta 2, all right? Oh boy. You know, forget about stress, all right? Forget about stress. This is, I just realized that it's just traditional vector summation. We don't have to take care, forget about all this. Well, by the way, it's supposed to be cosine absolute value of theta 1, by the way. But for now, forget about this absolute value, okay? Forget about stress. Or not. We just put this absolute value around this cosine theta, okay? So yeah, we'll do that. But we are just doing this traditional vector summation, okay? Yeah, for now, let's forget about absolute value. Let's forget about stress. We want to find out a formula, one single formula that can express addition of all vectors, force vectors. Okay? That's what we are trying to find out. Yeah, for now, let's do step by step, okay? Forget about stress vector, okay? Stress force, forget about it. We want to find out an expression. There are n vectors, many vectors, okay? We want to find out a single formula that express, also compress one single formula, that collapses. That's what we're trying to find out. Okay, so yeah, forget about stress. Just think about this transitional vector system. Okay. All right. Because we have to do step by step, really. Okay. Because I haven't seen any formula like that before. Maybe it's done somewhere by somebody at some time. Okay. Just time, space, and person. Maybe it was done somewhere, sometime by somebody. Okay. We don't have time to look up in the library. Okay, so we just do it, wing it. Okay. Oh boy. Okay. F A F B F C. Okay? We make it easy, right? We call it theta 1, alright? We just call it theta. Okay. No more subscripts, please. So, it's a vector, okay? Vector summation of 3 vectors, okay? FA plus B, okay? Vector summation of FA and FB, okay? F, we call this, oh my goodness, you cannot see this. You don't have to see me. F of A plus B, okay? This is equal to FA plus FB, alright? Now, you have this result vector, which is F of A plus B. And then you have this F of C. We call this theta phi. We call it phi, okay? Now, vector, can you see this? I hope you can. Running out of, yeah, you can see it very clearly. Oh, orange works good. Now, we add this together, okay? Then this, finally we have F of A plus B plus C, okay? Alright? That's the kind of formula we want to come up with, okay? We are adding F of A plus B plus F of C. That's F of A plus B plus C, okay? Summation of these 3 vectors, okay? We want to find the formula for that. When there are n vectors, 3 vectors, 4 vectors, 5 vectors, we want to find out this one single formula, mathematical expression for that. Okay. Forget about stress, this absolute value around cosine theta. No. Before that, we have to take a step back. And we have to do this first. In a traditional vector, force, acceleration, all that shit. Okay? We're going to take a break and we'll come up with it. Alright? After that, yeah, we'll throw this absolute value. That's too easy, right? Oh, come on. Okay? So we're going to step back and talk about this acceleration and acceleration of force. After that, it's just putting this absolute value around the cosine theta. That's just too easy, right? So, yeah, we take one step back. We are just getting rid of that stress force, getting rid of that cosine absolute value. We're getting rid of that. Okay. we do just traditional acceleration of force. After that, it's easy. Yeah, just call it stress force and put these two bars around the cosine theta. We take a break and we get back to this, okay? Alright? Alright. We have 1 hour left, so. Okay. Ah. Okay, so let's take a break, okay? We'll talk about something else. History of mathematics, okay? Very interesting. So Abel and Galois, they're like underdogs, young guys, okay, but very smart, right? But small guys, underdogs. They both died young, okay. And there's this Cauchy Poisson, like Poisson distribution, Cauchy Schwarz inequality, whatever, right? Cauchy stress tensor, whatever. Yeah, they're big figures. Poisson, Cauchy, they were like Poisson, Cauchy. Yeah, they were French mathematicians, very well established. So they are like establishment. Because back then, in 1800s, mathematics was the center of the world. It was a mainstream thing, mathematics, in 1800s in Europe. Okay, so the smartest people went to mathematics, not Hollywood, not business, not politics. No, smartest people in Europe, they went to mathematics. Okay, it's like power shift. Power shift from industry, one industry to another industry, like Evan Toffler said. Okay, uh, Evan Toffler. Okay, we talked about him. So, yeah, mathematics was center of the world. It's like mainstream thing, very popular and very prestigious. So yeah, a lot of money. The smartest people went to mathematics in 1800s in Europe. Okay, so yeah, Galois, Abel, they were like very underdogs. Okay, so they submitted some papers. It got rejected. Poisson, Cauchy, they looked at it. Whatever. Gauss. Okay. Yeah. Struggling actors in Hollywood. There was Abel and Galois. Okay. Underdogs. Okay. So it was like that. All right. So they wrote these papers and they were ignored. But later on, after they were dead. Yeah, it got rediscovered. Okay. So sometimes that happens in Hollywood too. There's this obscure writer who published a book, but nobody wanted to buy it. Nobody wanted to make a movie out of it. It's like this one, Nicolas Cage, this Living Las Vegas. Yeah, some casting director, whoever, just happened to get this book from the used bookseller. Oh my goodness, it's a great story. It got rediscovered after the writer died or something like that. Yeah, so they made it into a movie, Living in Las Vegas. I think that it got the Academy Award to Nicolas Cage. It's based on true story. Okay, so yeah, this underdogs in Hollywood as a writer, director, actor, actress. Yeah, it happens sometimes. Yeah, mathematics history is same. Okay, it's about fame, power. Okay, it's establishment and underdogs. Politics, business, it's all work the same way. Okay, so Cauchy, yeah, he's a great mathematician. We got it. I got it. Okay, but I think he didn't quite get it right in terms of the stress tensor. Okay, I wasn't quite satisfied with what he did. Just like I was not satisfied with what economist in Cambridge 100 years ago, Alfred Marshall did. I was not quite satisfied with that. So we came up with the better equation, transactional demand curve. Okay, we are doing the same thing here. Okay, all right. So, but before we get into the stress factor, we'll talk about traditional vector. Okay, vector summation. We want to express n vectors, many vectors, sum it up, we want to express in one single equation. It's algorithmic. It's easier to write an algorithm as a computer programmer, but to express that in mathematical language, it's a lot more difficult. Because in why is it easier to program it? Because we have this compiler programmers. It's a division of labor. Okay, it's a lot easier to program it than come up with just one single equation, because in mathematics equation you don't have a compiler programmers. Okay, so there's no division of labor. We have to do everything. Very primitive, you know. We cannot. I mean, in computer programming, we can write a recursive algorithm, a function that calls itself, right? In mathematics, oh my goodness, more primitive, okay? Pencil and paper kind of stuff. I'm just cooking my dinner in the microwave, okay? I popped in some Tums because my esophagus is yelling at me, barking at me. Oh, you are drinking vodka in the empty stomach. How dare you? Whatever. So, let's get back to this. We are dealing with transitional vectors, not stress vectors. Okay, not yet. We want to express summation of many vectors. We want to express that in one single equation. Okay. We are doing this because it's not been done before. As far as we know, it's not been done before. I haven't seen any formula like that. Maybe it's done by somewhere, sometime, by somebody, but I haven't seen one, okay? And we don't have time to go through these millions of mathematics books in the library, okay? I love library. I love mathematics library. It's like my heaven or haven, okay? I've been to mathematics library. It's so beautiful, but there are just too many books, and we don't have time to look through that, okay? So we'll come up with it. If it's done before, it will be rediscovery, you know, some different notation convention. We don't care, okay? We just need to know. We want to know, right? Okay. All right. So you have FA, FB, FC. Okay. We have theta between A and B. Okay. Okay. So vector summation. Yeah, we can call f as v as a vector, okay? Doesn't have to be false. But what's the difference, okay? It's a random character in the English alphabet. But in terms of A and B and C and D, we have to start calling A1, A1, A2, A3, A4, A5, A6, A7, okay? Because we have to generalize to n dimension, okay? So theta and phi. Again, we have to start calling theta 1, theta 2, theta 3, okay? We have to do it because we are trying to come up with an equation, one single equation that generalizes into n vectors, many more than 26 vectors, okay? So I'm just trying to convince you why we have to use subscript of subscript, okay? Index of index, okay? There's no other way around, all right? Okay. But for now, let's take it easy, okay? You got this picture, okay? My goodness. What did we get ourselves into, man? We are supposed to talk about humanology, but physicists, mathematicians, they didn't do their job, okay? Yeah, we know they have been busy doing something else. Busy with what? Huh? All this bullshit, man. Useless stuff. Maybe they were doing something important. I don't know. Okay? Maybe politicians, yeah, maybe they are doing something important but that we don't know about. Okay? We are supposed to do humanology, but mathematicians, they didn't do their job, so we are doing their job now. Okay? But yeah, we appreciate what they did. Maybe they were busy with doing something important. Maybe they omitted something, skipped something, and we are filling in the gaps now. Maybe we shouldn't criticize politicians too much. Maybe they are doing something important, okay? We are human beings. We cannot be perfect. We have to just help each other, you know? Yeah, filling in the gaps, okay? Yeah. Fine. Fair enough, okay? So f of a plus b plus c, we are doing the vector summation, okay? It's f of a plus f of b plus f of c, okay? Vector summation, which is equal to f of a plus b. We are adding these two vectors together first. The law of association, alright? Plus f of c, okay? And we call this theta the angle between f of a and f of b, okay? And we call this angle phi, okay? The result vector, summation vector, f of a plus b. Okay, we have f of a, okay? F of b, f of c. Now we sum f of a, fa and fb together, okay? Result vector is like this, okay? That's f of a plus b, okay? This was theta from f of a and f of b. Now, f of a plus b, angle between that and between f of c, we call it phi, okay? That's what it is. Alright? We have 45 minutes and I'm kind of drawing blank because I'm kind of getting sleepy, hungry, too hot. Sorry. It's challenging task for. It's good that I'm in Alaska, okay? Because in Alaska we don't have any distraction. isolated like a hermit. That's good because I can focus on this whatever scholastic endeavor and academic endeavor because I spent 2 decades in lower 48 in Midwest, West, East. I learned a lot. Now, because I have enough knowledge, I need some long time to develop my own knowledge. Okay, so it's good that I'm in Alaska. Okay. So, away from all the distraction and all the knowledge, establishment. Okay, like an exile, asylum. Okay, so, okay. F of A1 plus F of A2, okay? I convinced you we should use the subscript of subscript, okay? Plus F of A3, okay? The angle between the two, we call it theta 1. Now, the angle between F, then we have F after adding up F of A1 plus F of A2, okay? We add up these two vectors. Now it's result vector. The angle between this F of A1 plus F A2 and F of A3, we call it theta 2, okay? Getting cold again. I know, yeah, I'm sorry, it's so annoying, okay? You see me putting on, taking off this jacket, turning on, turning off heaters 100 times a day. I'm sorry. I don't want to catch a cold. Let's spell it out, okay? So this guy is equal to F A1 squared plus F A2 squared plus F sorry F A1 F A2 cosine theta 1, right? Yeah. When there's no vector hat, it's absolute value, okay? That's our notational convention, all right? Comes in handy, okay? So that's that. Now, oh boy, it's very recursive, okay? That's the magnitude of this vector, f of a1 plus a2. What's the direction of that? Well, it has some direction in the middle point, kind of, okay? By this diagonal of this parallelogram, okay? And we call this, so that's the, well, that's the magnitude, and it has some angle, okay? So it has some direction, okay? So You put a vector head over that shit, okay? And this vector, and f of a3 vector, it has some angle between the two vectors. We call it theta 2, okay? All right. Then what's that vector? Addition. It will look like this, okay? I will try to be as simple as possible, all right? So, but it's not gonna be that simple, okay? So I told you it's gonna be a mess. It will be like this, okay? F of, you know what? Maybe we have to come up with a different notation, okay? F of a1 plus a2, we call it a1 plus a2. We have to shorten this. Maybe we'll call it a1 2. Well, sigma ai from I is equal to 1 to 2. Ah, man. We'll just spell it out first, okay? Oh, boy. Yeah, it's so bulky and cumbersome. That's why nobody ever attempt to do this, okay? But we are diligent, okay? We are not only lazy, but we are also diligent too. Well, by the way, there's 2 here. I always forget the 2, sorry. 2, okay? Okay? You got it? Sorry. Yeah, I'm sorry, it's so unscrutable, ununderstandable, but, well, you have to excuse us, okay? Now we are getting the general pattern here. We have generic pattern, okay? How about when there's fourth vector? We have 3 vectors so far, right? We add fourth vector, it will be like this. This will be a4, this will be a1 plus a2 plus a3, okay? And this will be theta 3. Okay? Now we are getting it. Okay? Yeah. We'll take a break very soon, okay? But before that, let's take a shot at it, okay? It will like this, okay? So f summation of n vectors, okay? F is equal to uh, f of sigma let's call it, there are n vectors, okay? Sigma a I is from 1 to n minus 1, okay? Yeah, three vectors, yeah, n 1, okay? N squared plus f of a n squared plus 2 times f of sigma I is equal to 1 to n minus 1 ai, then f of an multiplied by cosine theta of n minus 1. We got it, okay? I think that's what it is. Okay, that's the summation. That's the summation of n vectors. Okay, we have one mathematical formula for that. I will close it up for you. Close up. Okay? I think that's what it is, alright? My goodness. Yeah, it's a recursive equation, alright? It has to be, okay? So, you're gonna take a break, okay? And then we'll do some. We get back to stress factor, okay? Oh, my God, this is such a long way home, man. We'll take a break, okay? So, okay. Yeah, take 5. Woo! Oh. Okay. We're gonna take a break, okay? So talk about something else. If I ever become very famous person, and if I don't pay individual attention to you, don't take it personal, okay? Because if I'm very famous, I'm dealing with a lot of people, and I'm not God. I'm only one person, okay? So if I become famous and if I'm not paying individual attention to you, don't take it personal, okay? Because I'm just too busy. Too busy. I cannot pay individual attention to you. I cannot afford that. I only have 24 hours, just like you do, okay? And I'm dealing with too many people. So I cannot pay individual attention to you, okay? So don't take it personal, okay? I know this because I deal with some famous people now. I'm not famous, but I write letters to President Trump or senators, congressmen, and what do they do? In reply, copy and paste, copy and paste. Same response. I understand that because they are dealing with too many people, you know. So yeah, I understand the dynamics. So I do. Okay? Okay? I'm just one person. It's not like I'm God or Son of God. No, I'm not. I'm not Jesus. Okay. Just Alaskan Asian as American, whatever. Okay, so. And I think this one works, okay? Let's plug it in, alright? So we got the nice formula. The vector summation of n vector summation, so, okay, the summation of multiple vectors. Let's plug in the numbers, okay? Let's see if it works, okay? I'm gonna zoom it in once again so that you can see it, okay? Because we have subscript and sigma in the subscript. I mean, who does that shit? Oh my goodness. Sigma in the subscript? My goodness, I've never seen anything like this before. And I've seen a lot of mathematics books. You got it? Huh? Yeah. There's sigma symbol in the subscript, man. Oh my god, who does this shit? It's something brand new, okay? Because we are very creative people. Let's plug in numbers, okay? Let's see how it works in when n is equal to 3. We are summing, adding up 3 vectors, okay? Okay? Vector summation of 3 vectors, okay? F squared sigma I is equal to 1 to what? 2 AI plus F squared A of A3 plus, okay, 2 times F sigma I is equal to 1 to 2 AI multiplied by F of A3 times cosine theta 2. Okay? We gotta move this whiteboard, okay? Tripod walk. Oh! 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 Re-angling. Well, guess what? We have plenty of space, okay? Which is equal to... Oh boy. f a1 plus a2 squared plus f of a3. I'm kind of afraid that if I did something wrong. Ah, if this equation is correct or not, I don't know. I'm proceeding very gingerly, very slowly. F of what? A1 plus A2, F of A3, cosine theta 2. Okay? Yeah, it's correct. Now we need to define what is f of a1 plus f of a1 plus a2. What is that? We didn't quite define that yet, huh? Oh boy. Yeah, it's not complete equation yet. Okay. It is very recursive. So this equation is not complete yet. Okay. It's incomplete because we are not quite expressing this recursive nature of this concept. Ah, boy. We have 20 minutes left. Okay, so yeah, we can do this. We have enough time. Let's think about this. I'm gonna switch out my vodka drinks. Okay, so why don't you think about it too? Okay. Ah, boy. Ah. Okay. We are almost there, right? Just about. We are almost there. We're making good progress here, okay? So 20 minutes, that's all we need. Less than that, actually, I think. I think we just need 10 minutes, okay? So every second counts, okay? We gotta make the best use of our every second of our time, okay? Yeah, it's kind of like stingy, just like some kind of CPA or accountant, whatever. Yeah, every penny counts, you know. Every piece of paper, yeah, we gotta spare it. Every second, every calorie, every penny, yeah. Just be frugal, you know, conservative, whatever. Don't waste any time or money or paper or penny, second, okay? Okay. Maybe we need two equations. I don't know. Okay. How about this? Instead of writing f of n here, what if we write this as we may have gotten it, okay? F of sigma a I is equal to from 1 to n. How about that? Okay. Then I think it works. Okay. I told you it's a minor tweak. We're almost there. Which is equal to f is ahead. Okay. Oh my goodness. Yeah, f. Okay. F a1 plus blah 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 plus an. Okay. Yeah, it's a vector. Okay. Well, actually, we're gonna forget about direction, okay? We'll just calculate the magnitude. Direction, who cares? Who cares about direction, okay? It's geometrical. It's important, I know. Come on, what is a vector without direction? If you take out the direction, it becomes a scalar, right? It's important, but yeah, it's embedded in this concept of theta, angle, okay? So, all right? But one thing at a time, all right? The direction, we'll deal with that later. We'll just deal with the magnitude, length of a vector, okay? So yeah, vector summation of n vectors, okay? You've fa1, fa2, fa3, fa4, blah, blah, blah. Summing it up, okay? I think this one works, okay? So, it's a recursive function, okay? Let me zoom it up. Zoom it up for you, like this. Okay? Panning the camera. Alright? Pan to the left. Okay? Pan to the right. Slowly. Okay? Zooming in. Alright? Ah, enough. Oh, my hands are getting tired. I'm getting tired. Oh boy. Yeah, I think we got it. Okay, so here, so recursive function is like this. We have n dimension here, n dimension. You are breaking it down to n minus 1 dimension. Okay? You're breaking down next step n minus 2, then n minus 3, all the way down to when n becomes 1. Okay? Yeah, so that's that. Yeah, if you want to prove this, yeah, go ahead, okay? It's a mathematical induction. When mathematical induction is a legitimate proof, okay? When we have generic formula like this, yeah, prove this formula is true when n is equal to 1. And then that's first step. Step 2 in mathematical induction proof. Step 2, assume that this formula is true when n is n. Okay? Then you prove that this formula is true when n is equal to, okay, sorry. First, you prove that this formula is correct when n is equal to 1. Next step, assume this formula is true when n is equal to k, right? Then somehow you prove that this formula is true when n is equal to k plus 1. Okay, it's like domino. Mathematical induction. Alright, yeah, just Google search, Bing search, okay, Yahoo search, whatever. It's a very powerful, good proof technique. Another proof technique is this, the mathematical induction, or you can have deduction, deductive logic proof, or you can prove proof by contradiction. Okay, so basically what you are trying to prove is, let's assume this formula is false, and then you come, it results in some kind of contradiction. Okay, so -1 minus -1 is +1. Okay, we assume that this formula is false, and then we came up with some kind of logical contradiction. So -1 times -1 is +1. Which means, yeah, we assumed this formula is incorrect, and then we resulted in contradiction, something false. So therefore, this formula must be correct. Okay? You're kind of disproving the negation of this formula. Something like that, okay? Yeah, in this case, this formula, the best way to go about it is just mathematical induction, okay? I'll leave you some of you as a homework, extra credit, whatever, okay? But if you want to. If not, you don't have to, okay? When I was a student, yeah, I did my homework, okay? For you, it's up to you, okay? Because this is not some college credit course, okay? It's for fun, okay? So I cannot give you any credit, like college credit, because we are not in formal institution. It's a hobby, okay? Do it only if you want to. I cannot give you any money, I cannot give you any job, I cannot give you any college credit, okay? Do it only if you want to, because I'm doing this for free, okay? It's not just you who is learning this for free. We are all volunteering our time, okay? So, do it only if you want to, okay? But we got it. We have 10 minutes left. Ah, boy. So how do we convert this into a stress force equation? Well, just put the absolute value in around the cosine theta m minus 1. Too easy, right? Oh. Yeah, that's that. Okay. And this is about pushing, okay? Pushing force. How about pulling force? Oh, it's just negative sign. Okay. Well, we have 10 minutes, okay? So let's be ambitious, all right? So we're gonna actually write down this stress formula, okay? 10 minutes, that's enough, okay? Stress formula is this, okay? Tentatively, all right? Hypothetically, because we don't know it's going to be correct or not, okay? So, oh boy. So there was a push, okay? So as push, we have push and pull, push and hold, okay? Stress of pushing is equal to this, okay? My goodness. Well, we are not gonna write this down, okay? Oh my goodness. Because we have this guy, okay? So push is f of okay. We're not going to repeat this, all right? It's just too long. Whole is well, we have to multiply two, huh? Oh boy. Oh boy. Oh. We have to do this tomorrow, all right? Because it's a lot. Because there's actionary force and reactionary force, and we have to take the absolute value of the two, and oh my goodness. Ew. And I don't know where I should put the absolute value, man. Oh my goodness. What a mess. We have 5 minutes left, okay? So let's take a shot at it, okay? So, oh, nightmare, dude. Oh boy. I don't think we can get through this in 5 minutes, all right? You know, time flies when you are enjoying something. Jesus said something very Einsteinian relativistic, okay? Like Jesus said, in heaven, 1 second is like 1,000 years, and 1,000 years is like 1 second. It's a relativity of time. Jesus said that like 2,000 years before Einstein, okay? Yeah, so when you're having fun, yeah, time flies, okay? When you are in pain, time is goes too slow, you know? Yeah. Oh, time is ticking. Oh boy. We continue this tomorrow, alright? Because we come up with this vector summation equation, okay? In a recursive manner, alright? Okay, so in this vector summation equation, there's one more term, alright? This is equal to sigma f a I when I is from 1 to n, okay? Which is equal to f a1 plus blah 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 plus f of an. Okay. Okay. We are just doing absolute value here, okay? So absolute value. Absolute value. Okay. Direction, I mean, we cannot quite quantify. I mean, it's an angle, right? But it's a kind of geometric thing, okay? So you cannot quite express this geometric thing in algebra. We have in mathematics there's geometry and algebra, right? When we geometry, you have to draw these pictures, okay? But we are dealing with equation here. Equation is more like algebra. It's like mathematical sentence. That's what algebra is. Geometry, you have to draw diagrams. It's more artsy, artistic, like triangle, circle. Okay. Yeah, geometry is more like fine art, sculpture, painting. Okay. Algebra is more like letters, like newspaper. It's a sentence. Okay. So we are doing algebraic equation. So that's why we are not dealing with direction. We are dealing with magnitude. All right. So okay. We have 30 seconds left. All right. Yeah. We are doing just magnitude. Okay, over vector, absolute value. All right. Norm over vector. Okay. So okay, we are running out of time. So okay. So thank you. We'll continue this tomorrow. Okay. Thank you. Bye.